Hey, my name is Escobar Benitez. I am from Colombia. Sorry about my slides. They are right now in PDF because it was a late notice that a lot of speakers were dropping out because this virus. So I didn't bring my personal computer with me. So the only way I could share my slide was via PDF. I give this talk last year at ElixirConf Latin America. If you don't know, there is an ElixirConf Latin America now. Last year was in Medellin. This year is going to be either in Cartagena or Medellin. So if you want to sponsor it, it would be really nice, and it would be you meeting Colombia, Medellin, or Cartagena, right? This talk is going to be about Elixir RabbitMQ, building Docker images via remote API. We are not using the Docker command line application. We are building images layer by layer manually in an automatic way. We are going to talk about that later. And using RabbitMQ for that. So who I am? I'm Simon. Simon. I have 3 dogs: Kiro, Pluto, and Jack. I have been working with Elixir for 3 years now. I did Ruby, JavaScript before joining Erlang Solutions, and the team behind this tool. In the real slides, their faces were spinning, but here they're static. His name is Brian. He has been a speaker in this conference too, and also he gave the training for Kubernetes. And the other guy is Felipe, who is also in the Americas team. He's based in Brazil. So what's the problem behind what we build? So we want to build a distributed continuous release pipeline to build Docker images on demand. Why? Erlang Solutions has a couple of own products that depends on a lot of dependencies. So what we were trying to achieve is hey, if a new dependency is released, we want to download that dependency, build our product on top of that new dependency, release a new image to the Docker Hub. So the QA team can download it, test it, and release a new version with that new dependency, right? The problem is Docker images until now, I think, because that's a beta feature, doesn't allow to include secrets in the images, right? So if you are trying to include SSH credentials, key user password, and stuff like that, you are not able to do it at build time. But you need to embed it in the image. And embedding credentials in the image is really insecure. So what we need to do is build an augmented Docker file to include that functionality via Docker Remote API. So that's why we build this tool. We call it BuildX. It is composed of multiple applications. One is the API, which is the manager node. It has a RESTful API. It manages the database, and it has an RPC interface. So we have other 2 applications that are going to call this manager node via RPC. The nodes are the puller node, who is in charge of pulling all the new repositories. And we have a jobs node, who is in charge of listening RabbitMQ to running those really heavy jobs, because creating Docker images is really intensive. And we have RabbitMQ in the middle. So what we do is we start pulling the admin, the manager node, asking for new repositories, or the admin asks us to start pulling a new repository, right? We ask GitHub for the new tags. We compare the local tags with remote tags to see if there is a new version. Right now, we are not using GitHub Actions or webhooks and stuff like that, because sometimes we don't own the dependencies, right? So the way that we know that there is like a new release is like they like publish the new release and tell everyone that there is a new release, right? Or we start like pulling those tags to see if there's something new. Then we, with the puller, put a job in the RabbitMQ. From the jobs, it's going to be consuming RabbitMQ to pull those images. And so far, it's like a pretty standard way of building applications, but we are going to see later on some gotchas and some problems that we had that that made us build like the puller in a distributed way, having like a distributed supervisor, distributed registry, and like some distributed features. So what is the flow? So in the admin or the manager node, we create like in the user interface like a repo. We add some tasks to the repo. Tasks are like based on Docker images or makefiles, because like some teams like use like really intensive like make. So we have like a really big makefiles that we can also run. We ask the puller like to start pulling. In puller, we are going to create like a process for each repo. We are going to start pulling as we asked for GitHub tags. We put a job in RabbitMQ, and the jobs manager is going to be consuming all those jobs. It's going to run the job task. The task, if it's a makefile, it's going to run the makefile directly. If it's a Docker file, it's going to parse the Docker file. I'm going to show you later on how to parse Docker files and how to give a context about each layer. Then we inject environment, because we have like a new tag and a new release. So those releases has like commit tags, the tag name, commit hash, and stuff like that. So we inject that environment into the image. So the image is able to grab that new commit tag to fit the new dependency. That's how we are doing it. We then build the Docker image, tag the image, push the image to Docker Hub, and we add the RabbitMQ that we already commit the image, and the job in RabbitMQ is marked as done. So in the process of building this, we spent more or less like 6-8 months building this, because we were like working on clients and also like in this tool. This tool is open source. I'm going to give you like the links for it, so you can check it out. So in the process of building this, we built a couple of libraries. This one first is the Xrabbit pool. There were like a lot of frameworks for RabbitMQ, like for publishing, consuming jobs, but every one of them has like its own way of like managing pools, connections pools for RabbitMQ. We at Erlang Solutions, we have like a unique team for managing RabbitMQ clients, and there are some core developers at RabbitMQ. We talked with them like how was the best way to build like a resource pooling for RabbitMQ, and we came up with this solution. The solution is like we are going to have like a pool supervisor. We are going to have like a connection pool, right? We are using Poolboy. So Poolboy is only for having like a pool of connection workers. So each worker is going to be open we are using like last in first out topology in order to widespread the access to connections. Because why? Connections to RabbitMQ are not through real connections, but into a multiplexed channel. So you can create like 16,000 channels in top of a connection. So what we need to do is like widespread the connection, and we are going to pull like channels of that connections. So for example, if you open 5 connections to RabbitMQ, in this case 4, each 4 connections can have like at most like 16,000 channels. So what we are going to do is like we are going to pull these resources here, not here. So the access pattern is like we ask like the connection worker, like, hey, give me a connection, right? it will going to give you a connection, and then you need to ask for a channel. So we don't block like in any transactional way the access to cont workers, but we block the access to the RabbitMQ channel. And also, because connection workers can have like different settings, because like if you connect to RabbitMQ as a way that you are publishing jobs, it's going to have a different setup that if you open a connection for consuming jobs, right? So if you are using the same connection for publishing and consuming jobs, you are going to have like really bad times, right? Because they are not built for that. So what we tried here is like separating concerns, building like a pooling way that you can like distribute the load and also distribute the access to RabbitMQ. Can you see it? Or should I open it on the editor? So this way, this is like the first connection pooling, only for connection pooling RabbitMQ library, because there were like a lot of opinionated frameworks that we don't want to use. This is only for pooling RabbitMQ connections. So you can create like multiple connections. For example, the first one is for producers, the second one is for consumers. We can tell like the size, the max overflow, and we are giving the user the ability to use the library as a library instead of an application. So the users needs to start or to put into their supervision tree the settings of how they want to build build this connection pool. So you have to start it manually on the supervisor. You pass like how many pools do you want, and the RabbitMQ connection for each one, or a global one if you want to. And for taking like channels, with channel, or you can grab like a connection by yourself, or your with channel, and that is going to pick a connection for you, and then it's going to open a transaction for picking up a channel for you. We wrote a really nice post explaining how we built this tool. It's in the Erlang Solutions blog. If you want to know like the details under the hood, you can read it. Then we built a Docker build. So Docker files and Docker doesn't allow you to include like secrets on your images. So what we have to do is like augment the Docker functionality, right? We have to expand like what Docker was able to do and inject custom functionality. So what we did was like parsing Docker files and adding extra commands, and I'm going to show you like how we built that. So right now we have like a path to project. You are going to give it like the name of the Docker file, and you are going to parse the file, and then you are going to build that parsed file. The path to project is because we need context to see like to tell it like, hey, as you are going to copy files from the project, as you are going to set the word here and stuff like that, we need to give it a context on where it's going to build that image. Let me see. Okay. Okay. The parser. Is built on something called continuations. So it's like a really big reduce operation where we start like taking each line. We start like asking like, hey, is this line like a full line, or does it have continuations? Continuations means like it's like when it has like this backslash for like using multiple lines. That's the only way to tell Docker like the lines continues in the other line instead of giving like full lines. And also we match like comments, continuations, and instructions. So from this, what we are going to get is like a tuple where we have the first element of the tuple being the command, given the run, from, add, copy, etc. And the rest of the part is going to be the rest of the command. We can see here like everything is fully tested. So for example, if we pass like a simple Docker file, this Docker file is like this from Elixir, tan, wordir, environment, run my run. We are going to have like a list of these tuples. So if you have worked with Elixir before, you know like a really good way of like executing each step of the image, because we already have the command, we already have the arguments for the command. So we are going to make like functions that take like this argument, and based on that, we are going to start executing the images. In this way, we build the Docker build. Docker build. This is like a simplified way. We start like executing each step, and we start like doing a reducer on top of that. Why? Because like Docker images needs to execute a command, and based on that command, we need to commit that that image, that container. It create a container, commit the container. That creates an image, and from the image, we need to start like a new image on top of that. So we need to reduce like each layer of the Docker file into a final image. So here we are like executing each step, and this is, for example, how we copy a file from one container to other container, or from one image to other image. So we need to get the archive, which is like the file. We create a container, we start a container, we upload the archive, we commit the archive, we stop the container, remove the container, and we have like from the commit the new image. That new image is going to be the base image of the next layer, right? So as how to copy a file from one file to another one, and how to start like the origin container. Some Docker commands need like the container to be running. So for example, to collect logs and stuff like that. And this is how we create like complete layers. So complete layers. Some commands need to wait for the image to be already available. Some of them not. So we added like a wait command, and we start like creating containers, starting the container, maybe wait the container if the container needs to be waited on or not. Stop the container, commit it, remove it, and you have the new layer. And in this way, I'm going to show you, for example, the run command. So we parse the arguments. We already have like the command here. We have the command arguments. We parse it. We see if it's a shell form or exec form. We give like some context. We merge the context, and we create a new layer. That's how the reducer works. So in the next step, in the next image, we are going to have like the new context. The image is going to be like the new image. So, and we increment the steps. In that case, we also have tests. Let me Docker build test. So for example, here I'm building like a really simple Docker file, and I'm asserting that it's the same logs that Docker build command executes. We are getting the same the same results, the same logs. And after that, I read the file, and I get my hello world. If you see here, there is like a blog post telling that Docker can do this, like can't modify a file inside a container at build time, and we are doing it, right? We are like executing an Alpine 3.8 container. We are mounting a volume in the current directory, so the current directory is going to be mapping a data directory inside the image. We are modifying the layer of the image, right? And then we are seeing that in the local container, we are going to see that file modified because like we modified the image and in the Docker file, like Docker, like normally would not have this image in the new layer, but in our case it has. Right? That's like the test case that we were willing to do. If we modify like a layer, it's going to be committed at build time, but it's going to be at build time the result, but it's not going to be embedded like in the final image. Okay, that's it. Let me continue. So yeah, this is like just a screenshot of showing like how it works. Unfortunately, like as this is not my personal computer, but in the client I'm working on, I weren't able to make it like a real demo. This is like how we build like the instructions step by step. I already show you like yes. Last year at October 2019, they told like, hey, we are not able to do that. But it seems like there's in beta, so it's not available right now. Maybe in the future, we don't know. Buildex common. Everyone knows that you don't have. You should not build name an internal like dependency like common util stuff like that. We didn't know how to call it, so we have like some behaviors. For example, the source. So we right now we have the GitHub source. It can be like a GitLab. You can build one for SVN or the one from Microsoft. I don't remember its name. Right, it's really simple. We have a behavior called runner that where we implement the make runner and also the Docker build runner here. And it's really simple. We get the task. Task is an internal structure. We start like getting the credentials from the task. Of course, the credentials are encrypted, so it's they are safe. We took the credentials. We start like parsing the content. We inject the environment. As we already parsed the Docker file, we for injecting like the new variables, the new commit tag and stuff like that, is only like adding new commands to it. So it is going to add like the new commit tag, the new release name, stuff like that. Then we build it. This is going to take like a couple of minutes, and if it fails, it doesn't matter because the job will fail, and we mark the job fail in RabbitMQ, so it will be retried. So no issue here. Then we tag the image, we push the image, and that's it. It's already on Docker Hub. That's what the buildx command does. It has like the internal structures. Everything is typed. We lob types, so yeah. The Docker file command is like really simple. We only like system make with the file name and some custom arguments that we are adding. After that, we have buildx jobs. Buildx job is really simple. It's just like we have the Xrabbit pool supervisor because we are using it in Pooler and RabbitMQ and the consumer side. We have a consumer supervisor. We have a couple of consumer. Each consumer is going to be a process consuming those work from RabbitMQ. And we have buildx pooler. Buildx pooler is where the problems begin, right? In this case, we have a similar architecture from the consumer. We have a pool supervisor for RabbitMQ, setup supervisor. Setup supervisor is going to have a pooler supervisor and a setup worker. The pooler supervisor is going to be in charge of spawning children for pooling GitHub, and the setup worker is going to be in charge of getting like the repositories that are able to be pulled from GitHub from the manager node, and creating the pooler processes on demand, like at the beginning of the task. So builder pooler. here. So we have the pool supervisor. We pass like the RabbitMQ, the pools, the setup supervisor. The setup supervisor has the pool supervisor and setup worker. The setup worker is going to we inject the database so we can test in local in unit test. We get all repositories and we start like our workers. Workers is like if we try to create like a process and the process already sees because we are naming the process the same way of the repository and the author of the repository. Try to spawn that and if it's already ready or if you success, like continue. If not, throw an error and stop it. If there is no database, just like retry. Maybe you can like we can add like a backup for connection stuff like that, but for now it's not necessary. So it's really simple, but the pooler, this is where the problem begins. Why? If you want, for example, multiple nodes to be pulling your dependencies, if you have like a bunch of dependencies, what happens if you are going to deploy a new node, or if you are like restarting your node because you are doing a new deployment? If you want to like increase your nodes, at this moment you are going to replicate all the processes in all the same nodes, or in all the nodes. So for example, if you have like 2 nodes, with this approach, you are going to have like 2 nodes with the same processes, right? If you have 3, 5, it's the same. So we want a way to distribute processes in multiple nodes. So for example, node 1 is going to have like a set of processes. Node 2 is going to have another set of processes, and so on. And we want to, if one node goes down, those processes are going to move onto other nodes until the new node comes back again, right? That is an easy task with React core, but no one besides like 10 people understands React core. So like we went like another approach. We found like a library called Horde. Horde gives you a distributed supervisor with a distributed registry. So when we first tried it, it was like you create a distributed supervisor registry. You spawn like multiple nodes. You join the nodes together and like set them like as a member of the cluster. But the problem is like when a node goes up or a new node joins the cluster, the processes were killed. So in some cases you don't want that, because like if the process is running, if like you have some state that can be moved into another node, you don't want that process to die, right? If you, for example, you are reading a file from the same node because any reason, you don't want that process to die and be like moved into another node. So we give them feedback. They change the behavior. So right now we have if a new node joins the cluster, the processes that are in the first node are going to stay there. But there's like another problem in that case. For example, if you are trying to increase the node size because there's a lot of load, or the first node is already like crowded, you will need to handle like moving those processes to another place manually, right? So there's a gotcha there. You can do it, but you need to be careful there. But it's totally possible, right? The nice thing about this is like under the hood, it uses like CRDTs. CRDTs is commutative replicated data types. Data types for like eventual consistency. I'm not going to talk about that. I'm not like super senior, like super knowledge in this, but I have read a couple of things. It's really interesting for like fixing conflicts in distributed systems. And that's it. Questions? I speak like really fast. Kevin, Oliver.
Yeah, I can get the mic. Thanks, man. Thanks. Nice talk.
Thank you.
You had mentioned that Docker doesn't let you bring secrets into the images. Can you talk a bit more about that? I wasn't sure how Docker would even know what you would consider a secret at that point.
No, I mean like, for example, if you have like a private dependency in NPM or Hex or stuff like that, you need to add like credentials, like user password or an SSH key or whatever key it's used for authentication. If you want, for example, to build your image using those private dependencies, you will need to include those credentials. So in the image, they are going to be stored there. So if you release your image or someone has access to your image, they can grab those credentials and see it plainly. Like these are, they don't allow that. So what we build is like you include the credentials, you use it there, the credentials, and as that is in build time, the final image is not going to have those credentials because they are discarded. That's how it works.
So you need credentials at runtime for some operation. That won't help.
No, if you need credentials for.
Let's say the AWS S3 bucket access.
Yeah, you can inject it as like a normal, in an environment variable. For example, with Docker Compose, that you can put like environments in the command line. That is already supported. But if you only want, for example, credentials for pulling your dependencies, build your product, and that's it, it won't help. There was like another.
Those two buckets covered.
Okay. Any other question?
Thanks, Simon.
Okay, thank you.